Hi, my name is Mike Cronin from NodeH. I'd like to show you a demonstration that we did recently in San Diego at the Femtocells America conference. A number of the people who saw the demonstration said that it would be very interesting for their managers or teams to be able to see this back home. So we're going to demonstrate it here and make the recording available.
Just to look at the setup here, it consists of a PRC 6500, which is the Femtocell platform itself. Next to that, on the top right, we have a netbook with a HSDPA USB stick. It's from Huawei, and it's capable of 14 megabits per second. In the center there, we have the core network Femtocell gateway simulator, which is a special software from NodeH running on an external laptop, which is communicating over IUH with the Femtocell. The core network and Femtocell gateway simulator from NodeH is a key part of our technology. It simulates a core network using a dynamic visitor location register. The interface to the Femtocell is pure IUH. The routing of voice and video call signaling as well as data for local loopback testing is supported. And the data gateway can fetch data from the local network or from the wider internet. Finally, it includes a gateway to an asterisk PBX, allowing calls to any phone on the planet. At the bottom of the diagram is the trace PC, which allows analysis both at the physical layer and at the higher protocol layer of the activity going on inside the Femtocell. And finally, we have a set of handsets. As you can see, they're from various different manufacturers.
This is a Percello PRC 6500 platform, so this is capable of 16 calls and high-speed data.
The first demonstration is UDP sent over the air interface to the netbook.
I'll just make the connection.
Using iPerf, we can pass data through the system at the maximum rate that can be handled by the RFs, which in this case, with puncturing, is a little bit higher than the theoretical maximum rate. The netbook with the Huawei 14 megabit dongle is the server, and the Femtocell gateway simulator is the client. You can see the data rates quickly climb up to about 13 megabits per second.
The theoretical data rate here is 12.8 megabits per second.
Puncturing allows us to achieve a little over 13. Exactly the same architecture is used for the FTP transfer, but this time we use an FTP client and there's a slight amount of overhead.
And here I'll initiate an FTP connection. And I can transfer a 100 megabyte file. And we quickly see the data rates climbing up to around 1350 kilobytes per second.
The significance of the FTP transfer is that it's real-world usage of data transfer. And interestingly, I can move the netbook into the room next door and have almost no degradation in speed. So as the FTP transfer runs to a close, we turn our attention to the primary initial use of Femtocells, which of course is voice calls. This is the architecture for the voice calls, and just to view how the signaling runs here, we see the ball representing the signaling sequence, going out the IUH, talking to the IUH simulator, and creating the call.
All these phones have been turned on and have registered on the Femtocell, so quickly I'll try to make the calls. So that's 6 calls active.
So with Purview we can see that in addition to the one data call, there are 14 voice calls currently active. To make the final 16th call, we will use a VoIP call out to any phone in the world. You can do this to any number of external calls, limited only by the processing power in the gateway simulator.
So what I'm going to do now is to make a call with the last slot that we have, the 16th connection. And what I'm dialing is just a standard Node H telephone. I accept the call. If I put this on speakerphone. Hello? So that's a call going over the live network. You can hear a delay, and that's the jitter buffer, because you could be talking over VoIP over quite a distance all the way around the world.
So here we can see that all 16 connections are now being used. It's very interesting at this point to start another data traffic transfer. Here we can see we're transferring a 20 megabyte file, and the actual data speeds reached vary from anything from about 5 to 10 megabits per second. So we can see a 20 megabyte file transfer, and it's completing in about 30 seconds. This is achieved using the spare data codes available and the spare processing bandwidth within the system. As you can see, at these sort of data rates, that is quite a bit. So just to recap what we've seen here, we've seen a high-speed data call at 14 megabits per second, a further 14 calls which were locally looped through our IUH simulator, and finally an external call to any phone in the world, and enough performance left over to do 8 megabits per second HSDPA. You've been viewing the Node H San Diego presentation. Thank you very much for watching.